Okay, this is the final part of monohybrid crosses. This is part 3. And for this one, all I'm going to tell you is Dad is heterozygous for eye color, and Mama is homozygous recessive. What are the possible phenotypes if they have children? Stop the video, work it out. When you've finished it, turn it back on and I'll give you the solution. Okay, so the solution to this one, we know that Mama is one's homozygous, the other's homozygous recessive, the other's heterozygous, which means this must be the genotype of what the heterozygous parent, big B, little b. Homozygous recessive has to be little b, little b. So that's the genotypes. So showing them like this, right? That would be what your genotypes look like. We'd have a big B and a little b chromosomes for this parent, a little b and a little b for the other parent. After, and that would be their somatic cells, their body cells, because they're in pairs. After meiosis, where we produce the gametes, okay, so we've got gametes here, we would have a big B gamete, and then all the other gametes would carry the little b allele, the blue allele. So going to my Punnett square, this is what it looks like. So big B, little b would give me a heterozygote, big B, little b, heterozygote, and then 2 homozygous recessive, which would look like this. So big B, little b, brown, big B, little b, brown, little b would give me a blue allele, a blue eyes. The phenotype would be blue. Little b would be, phenotype would be blue. So the question I gave you was, what are the potential genotype and phenotypes of their offspring? 50% of their, correction, there is a 50% chance each offspring would be heterozygous. There is a 50% chance each offspring would be homozygous recessive. In fact, just like the parents. So there is a 50% chance that there would be a brown-eyed child and a 50% chance the child would have blue eyes each time. There is a 0% chance of a homozygous dominant. There's no way any of their children could be big B, big B.